Module 4, Performance in a Virtualized Environment. It's important to understand that virtual machines and physical computers have many important differences regarding performance. These differences include the monitoring tools available and the overall performance troubleshooting methodology. Lesson 1, Performance Overview. By the end of this lesson, you should be able to meet the following objectives. Review components of the VMware ESXi architecture, describe fundamentals of performance, define a performance problem, and discuss the VMware vSphere performance troubleshooting methodology. Virtualization architectures with VMware includes two types. You've got your hosted and your bare metal. Now, in the hosted architecture, which we see right here, you'll notice that the virtualization layer, which is VMware Workstation right here in this instance, it runs on top of the operating system and supports like mostly the broadest range of your hardware configurations. But in contrast, you now have your bare metal architecture. And what that is you install the virtualization layer directly on a clean system. And because a hypervisor has direct access to the hardware resources, rather than going through the OS, this architecture, the bare metal architecture, is more efficient than the hosted architecture. And as a result, a hypervisor or the hypervisor delivers the greater performance and scalability option. When looking at your ESXi architecture, your ESXi is a platform for running your VM on a physical host, and the VM kernel does not run your VMs directly. What it does is the virtual machine monitor, your VMM, is a thin layer that provides the virtual x86 hardware to the guest operating system in the virtual machine. It is through the VMM that the virtual machine leverages key technologies in the VM kernel, such as your memory management, your scheduling, and the network and storage stacks. Each VMM or your virtual machine monitor is devoted to one VM, and to run multiple virtual machines, the VM kernel starts multiple VMM instances. Now, in this situation, the VMM then handles the CPU and memory virtualization as well as some of the aspects of the device virtualization. Then the VMware kernel storage and network stacks manage I/O requests to the host devices through their device drivers. Now, once all that's set, the VM kernel resource management component then partitions the physical resources by using a proportional share schedule to basically allocate your CPU and your memory usage, and your network traffic shaping along with allocating your network bandwidth, and acts as a mechanism to allocate your disk I/O bandwidth as well. And in this, basically this slide that you see here, you see that the CPU is controlled by the scheduler and virtualized by the VMM. So then your memory, which is right here, is allocated by the VM kernel and virtualized by the VMM. And then you go to your network and storage I/O devices are proxied through native device drivers, which are here, your NIC drivers and your I/O drivers, down to your physical host. When looking at virtualization performance, your first dimension side of it, a virtualized environment has several factors that affect performance, and these factors can depend greatly on the dimension of your virtualization platform. Now, in a physical environment, a one-to-one correspondence exists between the guest OS and the physical hardware, and the guest operating system and its applications run directly on the hardware of the physical host. But in a virtualized environment, the guest OS and its applications do not run directly on the physical hardware. Instead, they run on the virtual machine, where the VMM resides in the hypervisor and is responsible for the execution of that VM. Now, the first dimension, as you see right here in this slide, a virtualization is a single virtual machine on a single physical host, which you have right here. So the hypervisor then sits between the virtual machine and the physical hardware, which is here. And the first dimension factor that affects performance in VMM is overhead, which I got these backwards right here. You have your host here, and then you have your VMM here. At the second dimension, the virtual machines must share the resources, and when that happens, the hypervisor sits basically between, which we got right here. We have the hypervisor right here. It's sitting in between the host here and the virtual machines. Now, the hypervisor sits between the virtual machines and the physical hardware, and then the hypervisor, it schedules the virtual machines to run, and it coordinates access to your memory, networks, and your other storages. Now, when looking at the third dimension of your virtualization, here you'll notice you have your DRS scheduler or your distributed resource schedule cluster, and you can pool the CPU memory resources of multiple hosts, so virtual machines are no longer tied to a single host. But however, a cost is associated with running VMs in a DRS cluster, and one cost, for example, is the amount of vSphere vMotion migration that the DRS cluster performs to balance your VMs across multiple hosts. Now, this third dimension, it also reduces the impact of the second dimension performance issues. And one thing to note also is a third dimension factor that affects performance is aggressive VMware vSphere vMotion migration. So as you see right here, in between each, we have your virtual machines basically on two separate instances here. It's kind of slit down the middle. You got your hypervisor running in between here, which we're going to use vSphere vMotion, and right here are your hosts going across. One thing to take in consideration with your performance factor in your vSphere environment is if you overcommit your hardware resources, you may see performance bottlenecks. And an example of this is basically if you've got too many VMs that are CPU intensive, you'll see that performance slow because of all the VMs. They need to share that physical CPU it's running on. So in addition, your performance can suffer due to imbalances in your whole system. Now, this possibly, or it could affect or could apply to your physical and virtual environments as well. And expectations must be set appropriately when looking at your performance with this. Now, one thing to also consider is your configuration issues or user errors might lead to poor performance. And when we say poor performance, a good example of this is you may also see a situation where a user sets shares but then forgets about resetting them. And doing this may result in poor performance because of changing characteristics of the VMs in the system. And another example would be is that you might want to configure your LUNs improperly so that two VMs are accessing different LUNs that span basically the same set of underlying disk drives. And in that case, you would see worse disk performance than expected because of the contention for the disk, or they're competing for each other. Because of the abnormal access patterns, they're trying to access it in a abnormal fashion. So a user might also be using a symmetric multiprocessing virtual VM when a single processor VM would suffice for this instance. It is a best practices for performance. Kind of comes down to you knowing your application's characteristics. And when I say that, it is the application that benefits from your performance tuning efforts. And you configure your VM to provide the best possible environment for your application to run in. So if supported, you'll always want to use newer hardware platforms because they may have the latest features for improving your system performance, and use the VMware vSphere monitoring tools on a regular basis to monitor your environment. Now, as you see right here in this slide, it hits on the basis of understand the account for the target applications profile and the workload characteristics. You want to optimally configure your VMs. You want to improve your virtualization performance by using newer platforms when available. And you want to monitor your consolidated workloads closely to discover your new bottlenecks on a quicker basis. And as you see here, this is about the best performance layout that you can get as far as best practice. When we talk about problems with your performance management tracks and analyzes the achieved performance to ensure that those requirements that you set are met. Now, a complete performance management includes collecting and maintaining baseline performance data for all of your applications, any systems you have, subsystems, and that can also include storage and networks. Depending on your SLA or your service level agreement, a performance problem may be in the form of excessively long response times or throughput below some of your defined threshold as well. Now, if no SLAs exist, then the perceived performance problem can be quantified by basically comparing your current performance metrics to your baseline performance data. And if you decide that the difference is severe enough, then you'll want to troubleshoot to bring performance back within that range that you have set in that baseline. Now, in an environment where no SLA or your service level agreements are established and where no baselines are maintained, the users sometimes start to complain about slow response time and poor throughput that may lead to performance problems later on down the road. And in that situation, you need to identify or define a clear statement of the problem and set a performance target before doing any troubleshooting or performance troubleshooting steps to kind of help maintain that baseline. So with that being said, when a user reports that slow response time or poor throughput, I would go ahead and look at your baseline and kind of get an idea of what's going on and try to get, I would say, initially on top of it and kind of monitor the situation just to make sure it got no worse. Once you've monitored your baseline or your performance troubleshooting or your performance a little while, there becomes a methodology that VMware sets, and it kind of helps you provide guidance on how to find the root cause of the performance issues and maybe how to fix them. So some of the things, like your first step needs to be decide on the criteria for the successful completion of your performance troubleshooting methodology, your SLAs, your baseline data, or understanding of user expectations. You'll need to know the process of setting your SLAs and select the appropriate performance goals as well that is beyond the scope, that is kind of beyond your scope. Now, setting SLAs and goals is critical to you successfully troubleshooting your performance. And without these defined goals, your performance troubleshooting, it can turn into a long process. It could be an endless performance tuning, which you could make a change, and that every change you make may consist of another change happening. So that's why this methodology is kind of in place that VMware says that you kind of need to follow. Once you've kind of got your goal or what you want to look for right there, you need to then decide where to look for the problem. You can start to investigate the problem in several places, and there's many different ways you can go about doing it. Now, the goal of this performance troubleshooting is to select at each step the component that is most likely to be responsible for the observed problems. Now, that kind of goes on where I say you may want to monitor the situation a little bit so you can get a little bit, so you can observe a little bit deeper on where the problem's coming from as well. Once you have that problem identified, then you want to determine the cause of the problem and understand the solution for the problem and how to resolve the problem. Now, after you have identified and resolved that issue or that problem, the performance of the environment should be reevaluated in context of your completion criteria, which we go on your goals. And once your goals or your criteria is met, then the troubleshooting, you're complete. Otherwise, the problem check should be followed again to identify any additional problems if you didn't do that. And just know that in any performance tuning or troubleshooting, you'll only want to fix one problem at the time so that the effect of each change can be properly understood, and you'll know what you did and how to go back and address that problem if you later identify that same performance issue. Then you can go back and you've already got that criteria set and that goal set on how you did to resolve it. Here we're going to look at some basic troubleshooting guidelines or a checklist for your ESXi host. And just know that a large percentage of performance problems in a vSphere environment are caused really by minimal problems. The vSphere troubleshooting methodology, it is there to follow a fixed order flow through the most common observable problems or issues that may exist. And for each problem, there are checks identified or specified for each performance metric by or set by each vSphere performance monitoring tool. Now, as you see in this slide here, this graphic, what we see here, it represents a basic troubleshooting flow for your ESXi host. Now, the problem checks in this flow cover the most common or serious problems that cause performances on the ESXi host. And it's defined in three ways. You got your definite, your more likely, and your possible problems. Now, the definite problems are conditions that have a direct effect on the observed performance and should and really need to be corrected almost immediately. And your likely problems are conditions in most cases that lead to performance problems, but in some circumstances, they don't need to be required. They don't necessarily require to be corrected or required to be looked at immediately. And then your possible problems or your solution or possible problems, they may indicate performance issues, but also may reflect normal operating conditions. And the normal operating conditions, I want to hit here a little bit. You may be really using your network really heavily or your VMs and may have high memory usage, or you may have memory swapping between VMs. So just know that your possible problems doesn't really necessarily have to be fixed or looked at immediately, but your definite problems such as your dropped receive packets or your resource pool CPU saturation or your active VM memory swapping or your overload storage device time or overload to storage device needs to be checked. That's a definite problem that needs to almost be corrected then, because if you don't correct that, then that definite problem more than likely will lead to bigger problems later on down the road. Now that we've kind of went over this, you should be able to meet the following objectives. You should be able to review components of a VMware ESXi architecture, describe fundamentals of performance, and define a performance problem, along with discussing your VMware vSphere performance troubleshooting methodology.